So this is the second video for Math 83 for solving equations by factoring. If you have not watched the first one, please watch it first because we're really just picking up here where we left off in the last one. So what we talked about, this is going to be example D. I can't even remember if I was labeling them in the last video, but this is example D in your notes. So this is what example D looks like. And if you remember from the last video, we said that we can solve an equation like this by factoring if one side of the equation is 0. And that is not what we have here. So we're going to have to choose a side to make 0. And honestly, it doesn't make a difference at all which side is 0. Just one side has to be. It's less work for me to subtract this 2y on both sides. So that's what I'm going to end up doing and just make the left side 0. Either way, it works the same way. Now, if you wanted to subtract 5y squared on both sides and add 3 on both sides, that would be fine too. Might look a little weird to factor, but it would work out just fine. So I'm going to decide to subtract this 2y on both sides so that my left side is 0. And like we talked about in the last video, I'm going to put the 2y in the middle just because that's how we're used to seeing it. Now, on the last example, in the last video, we did something like this by guess and check. It cannot have been the same problem. No, good. All right, it's very similar to the last problem. Or I hate to call it guess and check. We did it by trial and error. And I promised I'd do an AC method here. So using the AC method, our product has to be the same as the product of the first number we see and the last number we see. So that's going to be -5 times -3, which is -15. And the sum always has to be the same as the number in the middle. So if we think about factors of -15 that sum to -2, first thing we know is that they have to have opposite signs because the product is negative. And since the sum is negative, we know that the bigger number has to be negative. So if we just start out here, -15 and 1, no, won't take us long though to get to -5 and 3. Now remember what we said in the factoring videos, that we're going to use -5 and 3 to rewrite -2y. So all we did was break up the -2y into -5y and +3y. And what we should be able to do at that point is factor by grouping. So each one of these contains a factor of 5, and each one of these contains a factor of y. So we can factor out a 5y from both of those terms. And we end up with just a y left over. And don't forget, if you ever factor out an entire term, there is always a 1 left over. And if you remember from factoring by grouping, what we're looking for here is being able to take out a greatest common factor out of these two terms and also end up with a y minus 1. And sure enough, they each contain a factor of 3. And whenever we factor out a 3, we are left over with a y minus 1. Y minus 1 is the same, leaving us with a 5y plus 3. And we factored it by AC method. Now, if you compare it to the last video, or the last example we did in the last video, trial and error saves you these 2 lines of work. So you're always free to factor by trial and error if you want. I just like this because there was a lot less guessing and checking in this method. That's just my personal preference. It's completely up to you. But now we're at the point where we have 2 expressions multiplied together and the product is 0. So what we can do is set each one of those expressions equal to 0 and solve the equations. So this one's pretty quick. We add 1 on both sides, and one of our solutions is y equals 1. This one has one extra step, but still nothing we've never seen before. Divide both sides by 5, and I'm likely running out of room. I am. So we get another solution of, where would I put it? Over here. Y equals -3 over 5. We could put a little or here if we want to. So again, we have 2 solutions. Y equals -3 over 5 or y equals 1. But again, they just came from setting each factor equal to 0 and solving the little linear equation that results. All right, let's do another one. I just want to show you this one, not because it's more difficult, not because it's even really different from what we've done before, but I want to show you something you might see as a solution so that you know you're not incorrect. So this would be example E from your notes. This time our variable's S for no reason, but the variable could be any letter. In this case, it's S. We see we are not allowed to start yet because one side is not 0. So our first job is to make that side 0 by subtracting 6s on both sides. I put it in between these terms just because that's how we're used to seeing it whenever we factor. Okay, now this is one where the leading coefficient is 1, so this one's going to be quick. We know exactly what those factors look like. They're each going to have an S in them. And now we have to have two numbers here that have a product of positive 9 and a sum of negative 6. So we know that these two numbers have to have the same sign and they have a negative sum. So we're looking for two negative numbers here. We know that right off the bat. And if we think about factors of 9 that add to 6, 3 and 3 will do that. So sure enough, s squared minus 3 gives us minus 6s and positive 9. And so once again, now we have two factors multiplied together and we get a product of 0. So we can solve the equation by just setting each factor equal to 0. Well, these are pretty quick. Add 3 on both sides and add 3 on both sides. So we end up here with two solutions that are exactly the same number. So they are two solutions, but there's only one unique solution here, meaning that we have two solutions, but they're exactly the same number. They're not distinct solutions. So there's just one distinct solution here. Depending on what kind of book you use or what kind of teacher you have, you might need to write both of these down, but really there's just one solution. So in my opinion, it doesn't matter. You can write 3 twice if you want, or just write 3 once. It really doesn't make a difference. That is the solution. Okay, so you might see that happen. So far, we've seen these things having two solutions, and every single time they've been distinct. They've been two separate solutions, two different solutions. Sometimes, though, you just get two solutions that are exactly the same number, and that's okay. This next one I want to show you is just so you don't forget how we factored something like this. Okay, so first of all, let's appreciate the fact that one side's already 0, so we don't have to do any work there. Now our job is to factor this. Well, first thing we notice is that there are only two terms. That's not like anything we've factored so far in this particular video. We factored one with two terms in the last video, and it was a difference of squares. So we look at these. 3 is not a perfect square. 6 is not a perfect square, x is not a perfect square. So this is not going to be a difference of squares, at least right away. Like we tried before, let's try a greatest common factor. Do these have a common factor? And we see that they do. They each contain a factor of 3, and they each contain a factor of x. So we can take out a factor of 3x from both terms. We'll see what's left. Take away a factor of 3 and we just get 1. Take away one factor of x and we're just left with one factor of x. All right, take away a factor of 3 and we're left with 2. Take away the factor of x and there's nothing. Okay, so we're used to seeing a factor like this. We're not so used to seeing a factor like this, but it's not really different. It's still a factor equal to 0, okay? So we still have two expressions multiplied together equaling 0, which means either one of them could be 0, or at least one of them has to be 0. So our job is still just to solve these two equations. What you can't forget that you are perfectly allowed to do is divide 0 by numbers. That's still fine. So we can still divide both sides by 3 here, and we just end up with 0 over 3, which is 0. So just don't forget about this factor. If you ever factor out a number with an x on it, that still counts as a factor you need to set equal to 0. And this one we would add 2 on both sides. And our other solution would be x equals 2. So here we have two solutions, and they are two distinct solutions, meaning they're two solutions that are actually different numbers. That's typical of what you'll see. One last one, and I just want to show you this one again so you don't forget what you're allowed to do and what you're supposed to do. So this one definitely looks like something we've never seen before. Okay. The reason why it looks so different, maybe a little bit scary, is because we have a y cubed here, and we haven't seen a y cubed yet. And in general, we don't know how to solve cubic equations in this class. So we're going to try to make it into something we do know how to solve. Well, first of all, one side's 0, and that is great because that means we can just get straight to factoring. We don't have to do anything extra. Now, this y cubed is probably a little bit irritating, but notice everything here has a y in it, so we can factor out y as a greatest common factor. And now this is looking a lot better. So remember, this y is just going to have to hang out because we factored it out right at the beginning. But now our job is to factor this part. So the y is still there. This has a leading coefficient of 1, so we know what the factors are going to look like, at least format-wise. They're each going to have a y. Now these two numbers have to have a product of negative 12 and a sum of positive 11. So because the product is negative 12, we know that these have to have different signs. And because the sum is positive, the bigger number is going to be the positive number. So let's start out here. Positive 12 and negative 1. It works. Okay, so these do add to positive 11. So these are our two numbers. And now you're in the same boat you've been in the whole time. Now, just this time we have 3 factors that we need to set equal to 0. Don't forget about that guy. So y could be 0. Y plus 12 could be 0. Let me erase this. Y minus 1 could be 0. And now we have 3 equations to solve, but one's already done. We set y equal to 0, that counts as a solution. But nothing to do. Subtract 12 on both sides here, so y is negative 12. That's another solution. Add 1 on both sides here, and we get a third solution of y equals 1. So we have 3 solutions here. This one had a y squared in it, so it gave us 2 solutions. That piece gave us 2 solutions. But we had this y that hung out till the end here. So if you have a y cubed that you see in your equation, you could end up with 3 solutions. So just look out for that. Try to factor it. It should always end up with a y squared or an x squared or an s squared, whatever your variable is. But it should always end up with something you know how to factor. And that is it for solving equations by factoring.